Today we're looking at a new way to work out if something is linear or nonlinear. So before we would have graphed each of these points, and then if it was a line we would say it was linear, and if it was a curve we would say it was nonlinear. But we're going to do something today where we called calculating first differences. So if the numbers in your x column are going up by the same increment, so here they're going up by ones, 1, 2, 3, 4, then you can do something with the y values called calculating first differences. And what this means is that you take the number at the bottom of the table and you subtract the one above it. So 25 minus 20 is 5. And then you do 20 minus 15, which in this case is also 5. 15 minus 10 is 5, and 10 minus 5 is 5. So if these are called your first differences. If your first differences are all the same, then that means that this is linear. And if it's linear, we can create an equation y equals mx plus b. So to find your m, you could use the y2 minus y1 over x2 minus x1 formula. However, if these numbers are going up by ones, and only if they're going up by ones, you can just use this number here. So our m is 5, and then and that's our slope. To find our initial value b, you go to 0 in the x column, and your b is the y next to it. So in this case, b is also 5. So then your formula y equals mx plus b is y equals, instead of m you put 5, x plus b, instead of b you put 5. So your formula is y equals 5x plus 5 for this linear equation. For this one here, when you go to calculate the first differences, 16 minus 9 is 7. 9 minus 4 is 5, 4 minus 1 is 3, and 1 minus 0 is 1. So these first differences are all different, which means that this is non-linear. So if you were to graph it, it would be a curve, not a line. And we can't find an equation for this because it's not linear. Let's take a look at this one. So 28 minus 21 is 7, 21 minus 14 is 7, 14 minus 7 is 7, and 7 minus 0 is 7. And because these go up by ones, these first differences, that are all the same, they all equal 7. And then your b value, you find the 0 here in x, and whatever your y value is, that's your b value. So b equals 0. So our formula y equals mx plus b. You put 7 for m, and you could put b, but you don't need to, because b equals 0, and plus 0 doesn't change anything. So your formula or your equation for this is y equals 7x. So let's have a look at these diagrams here. These are supposed to be toothpicks laid out to create diamonds. So the first thing we have to do is fill in this table. Then we're going to create an equation and use that equation to work out how many toothpicks we would need to have 10 diamonds. So here, to have one diamond, we have 1, 2, 3, 4 toothpicks. So we can put 4 here. Here we have 1, 2, 3, 4, 5, 6, 7 toothpicks. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks. So let's check if it's linear. 10 minus 7 is 3. 7 minus 4 is 3. And if you continue drawing this pattern and working out the number of toothpicks, it would keep going up by 3s. So to create this equation, our m value will be 3, because the diamonds are going up by ones. Now we don't have a 0 in our table. But if we were to go back here, so 3, 2, 1, 0, and we were to count back by 3, so 10, 7, 4, 1. So you would get 1 here, 0, 1. So your b value is 1, because when x is 0, y is 1. And I realize that this may not work specifically in the diamond sense, because when there's 0 diamonds, there's going to be no toothpicks. But for the sake of keeping this pattern, we follow the pattern to find that b equals 1. So our equation then can be y equals mx plus b, where y equals 3x plus 1. And what you could even do, because your y values are toothpicks, is you could do t equals, for toothpicks, 3, and then for x you could do d for diamonds. Now that we have this formula, we can use this formula or this equation to find the number of toothpicks used to create 10 diamonds. You could just keep counting up until you got to 10, or you can sub in 10 to your equation. So for 10 diamonds, instead of d for diamond, you put 10 for 10 diamonds. So t equals 30 plus 1, which is 31. So you can say, therefore, you need 31 toothpicks to create 10 diamonds.